everyone, this is Nirali Patel from your Aldi Institute of Engineering and Technology. So far, we have discussed about the statistical measures for the discrete random variables. Now, in today's lecture, we are going to start with measures of statistics for continuous random variable, and after that, we will see the examples on that topic. So let's get started. So let's first start with the measures of the statistics for the continuous random variable. So we have already discussed this statistical measure for the discrete random variables such as mean, median, mode, quartile deviation, skewness, kurtosis, variance, mean deviation, and all of that. Okay. But now we are going to discuss about for the continuous random variable. So the first one is the mean. So the mean for probability distribution of a continuous random variable x is called the expectation and is denoted by E of x. So we can write mu is equals to E of x, and that is equal to my integration from minus infinity to infinity x into f of x dx. The formula for mean in the discrete random variable is sigma I is equals to 1 to infinity x into p of x. So here, to calculate any statistical measure for the continuous random variable, this p of x is replaced with the f of x, and the summation is replaced with the integration for the given range. Okay, so that we are going to do for the remaining statistical measure as well. So for the any function of continuous random variable x that is denoted by phi of x, so expectation of that function phi of x is given by E of phi of x is equals to minus infinity to infinity phi of x into f of x dx. The next is median. We have already discussed that median is a point that divides the distribution into two equal parts. So in case of the continuous distribution, the median is a point which divides the total area into two equal parts. So the median m for the continuous random variable x is given by integration from a to m f of x dx is equal to 1 by 2, and that is also equal to integration from m to b f of x dx. Now, by solving this equation, you can get the value of the median. The next is mode. So the mode is value of x for which f of x is maximum. And the mode is given by f dash x is equals to 0 and f double dash x is less than 0, where x is lies between the a and b. Next is geometric mean. So the geometric mean for the probability distribution of continuous random variable x is given by log g is equals to integration from minus infinity to infinity log x into f of x dx. Similarly, harmonic mean of probability distribution of continuous random variable x is given by 1 by h is equals to minus infinity to infinity 1 upon x into f of x dx. Next is quartile division. So the nth quartile of the probability distribution of continuous random variable x is denoted by QR, and that is given by minus infinity to infinity QR f of x dx equal to r by 4, where r could be 1, 2, 3. Now, if we take the r is equals to 1, so q1, and if we take the r is equals to 3, so that is q3. So q1 and q3 are the first and the third quartile respectively. The first quartile is also known as the lower quartile, and the third quartile is also known as the upper quartile, where q2 is the median, or we can say the middle or the second quartile, because as we have discussed, this is q1, q2 and q3. So this q2 is nothing but median. This we have already discussed during the discussion of the statistical measure of the for the discrete random variable. Now, to get the quartile deviation or the semi-interquartile range for the probability distribution of continuous random variable x, we have to apply this formula. So that is q equal to 1 by 2 q3 minus Q1. Next is mean deviation. So the mean deviation for probability distribution of continuous random variable x is given by mean deviation is denoted by MD. So MD is equals to integration from minus infinity to infinity x minus mu, where we have to take the absolute value of x minus mu into f of x dx. Next is standard deviation. So the standard deviation is nothing but positive square root of the variance. So for random variable x, the standard deviation is given by SD is equals to under root variance of x, and that is denoted by sigma. The variance for the random variable x is given by variance of x is equals to sigma square, and that is equals to integration from minus infinity to infinity x minus mu whole square into f of x dx. We can also write minus infinity to infinity x square f of x dx minus mu square. Now the next is the moments. The central moments, or we can say the moments about the actual mean for the probability distribution of continuous random variable x is given by, in general, mu r is equals to integration from minus infinity to infinity x minus mu whole raised to r into f of x dx. Similarly, row moment or the moment about the arbitrary origin for probability distribution of continuous random variable x is given by mu r dash is equals to minus infinity to infinity. Instead of mu, we have to write a, that is the arbitrary origin. So x minus a whole raised to r into f of x dx. Now if we take the value of a is equals to 0, so rth order simple moment is given by mu r dash is equals to integration from minus infinity to infinity x raised to r into f of x dx. The next is skewness. So the skewness for the continuous random variable x is given by beta 1 is equals to mu 3 square upon mu 2 cube. And kurtosis of probability distribution of continuous random variable x is given by beta 2 is equals to mu 4 upon mu 2 12. That is nothing but that is equals to mu 4 upon sigma raised to 4, because mu 2 is nothing but that is sigma square. So sigma square raised to square, that is the sigma raised to 4. And as we have discussed, the various measure of central tendency, dispersion, skewness, and kurtosis for the discrete random probability distribution can easily extended in the for the case for the continuous probability distribution by simply replacing p of x with the f of x dx, and summation is replaced with the integration over specified range of the variable x, as we have discussed during the mean for the continuous random variable x. So this is all about measures of statistics for continuous random variables. Now let's discuss about one example. So it is given that a continuous random variable has the probability density function f of x is equals to 6 into x minus x square, where x lies between 0 and 1. Find the mean, variance, median, and the mode. So for the mean, we can write integration from minus infinity to infinity x into f of x dx. And this could be written as integration from minus infinity to infinity, minus infinity to 0 x into f of x dx plus 0 to integration from 0 to 1 x into f of x dx plus integration from 1 to infinity x into f of x dx. Now here for range minus infinity to 0 and 1 to infinity, the f of x is not defined. So this two term would become 0. So we can write 0 plus integration from 0 to 1 x into f of x, that is nothing but 6 into x minus x square dx plus 0. So the 6 would become common. Integration from 0 to 1 x square minus x cube dx and 6. So for the integration of this is x cube upon 3 minus x raised to 4 upon 4 and the lower limit is 0 and the upper limit is 1. So 6 into 1 by 3 minus 1 by 4. So that would become 6 into 1 by 12. So the answer for main is 1 by 2. Now the next thing that we have to find is variance. So variance is denoted by sigma square, and that is integration from minus infinity to infinity x square f of x dx minus mu square. And this could be written as minus infinity to 0 x square f of x dx plus 0 to 1 x square into f of x dx plus integration from 1 to infinity x square into f of x dx minus mu square. Now for minus infinity to 0 and 1 to infinity, f of x is not defined, so this two term would become the 0. So we can write 0 plus 0 integration from 0 to 1 x square into 6 x minus x square dx minus mu square, because this would also become 0. So 0 to 1, 6 would become common, x cube minus x raised to 4 px minus mu square, and that is equals to 6 into x raised to 4 upon 4 minus x raised to 5 upon 5. Lower limit is 0, upper limit is 1 minus mu square. So 6 into 1 by 4 minus 1 by 5, 0 to 1 minus mu square. So that would become 6 into 1 by 20 minus 1 by 2 square, because the mu square is nothing but 1 by 2 square, so 1 by 2 square. So 6 by 20 minus 1 by 4. So the answer would become 1 by 20. Now the next thing that we have to find is the median. So for the median, this is our third case. So as we have discussed earlier, median is nothing but to find out the value of mean, we have to take the integration from a to m f of x dx, that is equals to integration from m to b f of x dx is equals to 1 by 2. So we can write integration from a to m f of x dx is equals to integration from m to b f of x dx, that is equals to 1 by 2. So we can write integration from a to m f of x dx is equals to 1 by 2, where a is nothing but the lower limit, that is 0. So for that we can write integration from 0 to m, and the value of f of x is 6 into x minus square dx is equal to 1 by 2. So 6 would become common, 0 to m x minus x square dx is equals to 1 by 2. So that implies 6 into x square by 2 minus x cube by 3 is equals to 1 by 2. So we can write lower limit is 0 and upper limit is capital M. 6 into m square divided by 2 minus m cube divided by 3 is equals to 1 by 2. So the answer for this would become 3m square minus 2m square is equals to 1 by 2. That is equals to 6m square minus 4m square minus 1 is equals to 0. This is minus 2m cube. So this is also minus 4m cube. So we can write 4m cube minus 6m square plus 1 is equals to 0. Now the one factor for this is 1 by 2. So we can write m minus 1 by 2, m minus 1 by 2 and m minus 1 by 2. So 4m square. So 4m cube minus 2m square minus 4m square. So this would become minus 4m plus 2m minus 2m. So this would become minus 2 plus 1 would become 0. So the one is m is equals to 1 by 2 and second 4m square minus 4m minus 2 is equals to 0. So we can write 2m square minus 2m minus 1 would become 0. Now to solve this equation, we can do this would become a, this would become b, and this would become c. So b square is equals to b square minus 4ac. So b square is 4 minus 4 into 2 minus 1. So that is 4 minus plus 8. So that is under root of 12. That is your t. So the two roots for the m is nothing but minus b plus or minus b upon 2a. So minus b, that means 2 plus or minus under root 12 upon 2 into 2. So that would become plus or minus 1 by 2 upon plus or minus root 3 by 2. So we can write 1 plus or minus under root of 3 by 2. That is the two roots of the m. So we can say that the value of m is lies between 0 and 1. So this is the value for the medium. Now the next thing that we have to find is mode. So as we have discussed, for the value of x for which f of x would become the maximum, that is the value of mode. So fourth is mode. Let's first find the f dash x, that is equals to 0. Now f dash x is equals to nothing but f of x is equals to 6 into x minus x square. So that is 6 into 1 minus 2x, that is equals to 0. So the value of x would become 1 by 2. Now for f double dash x, so the value of f double dash x is equals to 6 into minus 2. So that would become minus 12. So for x is equals to 1 by 2, the f double dash x is minus 12, that is less than 0. Hence, f of x is maximum at x is equals to 1 by 2. So the value of mode is equals to 1 by 2. So this is all about today's lecture. In next lecture, we will discuss some more examples. Till then, keep exploring and thank you.